Hi, everybody. We're about to start. Thank you. So today, Aaron Hall is going to present us Slot or Not, Higher Performance.
Thank you. Welcome. I wanted to start off with a too long didn't watch for our potential watchers on YouTube. The basic idea of this talk is that slots should be used by libraries that encourage reuse. They save space and they are faster. If you're new to Python, you don't have to worry about them. If you start using them and you then want to stop, you can easily take them out without breaking, and that's assuming your program finishes on time and doesn't run out of memory. And if you add them to an established lib, you could break subclassers if they are using slots. And this is basically what slots are, how you would declare them. You would declare them with a class, and you have this dunder slots declaration here, and you can use a tuple or a list, and you can also add a dict, which would allow you to dynamically add attributes. The Tao Te Ching by Lao Tzu. The translation by R.B. Blackney, I think, is quite apropos to a discussion of object-oriented programming in Python. There are ways, but the way is uncharted. There are names, but not nature in words. Nameless indeed is the source of creation, but things have a mother, and she has a name. So how do we deal with data and functionality? Objects let us do this. Objects are the intersection of data and functionality. We have dicts, which are generic objects, and module-level functions. That's one way of dealing with data and functionality. We have inheritance, which allows us to have code reuse. We can reuse code with mixins, and we can get abstractions, which give us interfaces that we would expect in our objects. The downside of dicts is they are untyped. If we use dicts and we pass them around, we can just dynamically put whatever we want in a dictionary, and it has that key value pair. But objects provide typing. And of course, in Python, everything is an object. So custom Python objects store data, and by default, they store that data in a dunder dict. We have a new dictionary in Python 3.6. I have done some analysis of the size that they now take up. It's considerably less than what they did before. So as we add elements to the dictionary will pre-allocate space until it runs out of space, and then it pre-allocates more space. And so here's a sort of helper function that I created. It's on Stack Overflow. You could find it through that link. But basically, what we do is we take a given object, and then we take a given object, and then we recursively look at that object, get the ID, make sure that we don't look at it twice. We get the size of that object, and then we look at the things that are inside that object. So if the object has a dunder dict, we get the size of that. If The object has the dunder slots. We get the size of the things that are in that. So here's evidence that the new dictionary is not taking up as much space as it used to, or this basically describes the rate at which it grows. So when we get to 86 elements in our dict, it then grows to 4704 bytes. So slots, when we use slots for attributes in our classes, a slotted object won't take up very much space at all. When there are no slots, it takes up only 16 bytes of space. When there's 1, it takes up 56, 2, 64, 696, and it grows linearly like that. In 2.7, it took up an object without slots takes up considerably more space. And in Python 3.6, we now have some space savings, but it's still considerably more, at least 4 times as much. So the lookup order for dotted lookups is to look first for the name in the class MRO. If it's a data descriptor, it returns that result. Next, we look in the instance dict, and if our attribute is there, then we return that. Finally, we look in the class dict again for non-data descriptors. And I have an example that may make this more clear if you didn't quite follow that. So here's our example. So we have this example class. We have a property, and a property is a data descriptor. This property object that sits in the class dictionary has a dunder get, a dunder set, and a dunder delete method. And having the dunder set method makes it a data descriptor. Thus, when we look in this class, if we looked for a property in an instance, we would first find a property in the class. Methods are non-data descriptors, as well as class methods, static methods. Methods are non-data descriptors. We look these things up third. Attributes that are stored in the dunder dict are looked up second. So what we do is we look for data descriptors first. We look for the instance dict, and then we look in the class for non-data descriptors. And so what this means is we can overshadow things by sticking things in front of where we would normally find them. So we can overshadow the class method by sticking something in the instance dict. And so this demonstrates that we would basically overshadow the class method, and we'd have a function here that would just return foo. However, data descriptors sit in front of all of that, so when we put things in the dunder dict, we can't overshadow. So, and please never do any of this right here. So slots also, just like property, becomes a data descriptor. So that means they get found first in the lookup. However, because we have to follow the MRO, if it's buried deeply in a higher parent class, then we start to lose the lookup performance, which I demonstrated to myself yesterday. Or actually the day before, I got to buddy code with Guido a little bit. and to the benefit of going to PyCon. So they store the data when we store data with slots, they get stored in a struct or mutable tuple type structure. So you can think of it like a fixed length list, and it has the same kind of lookup performance for that. And so here's the evidence of speed. I had Del in here, and with Del, it's actually even much faster. But who uses Del? Has anyone used Del in here in production? I'm hoping not. Last time I did was in a while loop that was a very long running while loop, so I wanted to delete things that were no longer needed. But otherwise, when things fall out of scope, we don't use Del so much. And then when I took out the Del, the unslotted approach, the speed was not as great as the speed difference is not as great as when the Del is in there. But this is sort of a worst case, I think, scenario. And so the worst case here is 10%. So that means the slotted lookup is about 10 or 11% faster. Worst case of these. So okay, so a note on premature optimization. Premature optimization is unnecessarily adding significant complexity with the expectation of greater performance. And so you might have someone object, a reasonable person object to slots because it's unnecessarily complex. Best practice is known to get consistently better results. So I've given several best practice talks. Slots are not a best practice. There are trade-offs. And so I was supposed to say something about fitting angels on the heads of pins, but I think this is just as good. Okay, so there's some caveats for slots. We can inherit from objects with empty slots error-free. You can think of object as if it has empty slots. So you can just declare slots as a list. So there's an empty slotted object or a slotted object with foo and bar. So if all parents are slotted and there's no dunder dict in any of their slots, it prevents dict creation. So that means we can't just dynamically create things for example, this empty slotted class. So usage becomes complex in multiple inheritance, and that's where we start to maybe have an issue with it. Two non-empty slotted parents will not work. Only one at most can be non-empty slotted. So we only have one non-empty slotted, the slotted class there that we're inheriting from. And so that means this usage will work. Named tuples are another alternative to slots in terms of performance and space usage. But as per the documentation, they're not really intended to be subclassed. So this limits their reusability. You can still add functionality to them by subclassing them. It just doesn't give you as much reusability. So say we want to subclass two classes. This is going to create an error for us. Best practices, though, tell us we need to factor out interfaces and factor out functionality. So if we want, for example, bar to be reusable, we could make bar an abstraction, and then we could have our concrete implementation. We have some abstract properties that abstract bar has, And then when we subclass that to get our regular bar, all we do is we declare those as slots. And since those become data descriptors, these are now concrete properties, concrete implemented properties. And so bar works. And then when we want to get the code reusage from our abstraction, we can now subclass from foo and abstract bar as baz, and that works. Has pseudocode gone too far? Maybe. So if you're new to Python and/or writing objects, I would just suggest take it all in. Try to learn from this material. So says Uncle Bob, good architecture allows you to defer decision making as long as possible. And I would propose that slots can help you do that. Because if you want to remove slots, you can at any time. But you could potentially break if you add them in later. If you're a Python pro, I would suggest you consider pairing empty slots with abstract base classes and mixins, anything that you don't intend to instantiate. Give them empty slots, and then your subclassers can have objects that refuse to create just arbitrary attributes. Expect users to use your abstract base classes and mixins instead of directly inheriting your instantiated classes. And demonstrate the usage in documentation. I want to encourage you to ask questions now. Are there any questions? Remind me to repeat the questions if I don't. Yes. Yes. Yeah, probably tuples may be better, but it's fairly trivial difference. I mean, oh yes, thank you. The question is lists versus tuples to create slots. I don't think there's a technical difference. Aside from the fact that lists may take up a little more space than tuples. If you use lists to do it and then you try to add slots after you've created your class, then they're not going to have an effect. That's my understanding. Any other questions? So I've got more material after this, but that I didn't. I thought it was disposable, so I will continue, and I will encourage you to ask questions or interject. If you think I'm wrong, feel free to heckle me. So much talk means much exhaustion. Better far it is to keep your thoughts. Okay, so who's heard of the Borg pattern? I see a couple of hands. Well, I think I would consider it actually an anti-pattern. It doesn't make sense to me. The point of an object, of having instances, is so that you can have data points that you can directly use their functionality, right? So why would you have multiple instances that all have the exact same data? It doesn't really make sense to me. Maybe for testing purposes, it might make more sense. Okay, but if we add slots to the Borg pattern, it starts to make a little more sense to me. So that means we can have some unique state per object, as well as our shared state. But the problem with this is really it subverts what users will expect from your object. So, and will users be surprised? I think this violates the principle of least surprise, right? Am I right? I think I am. So with shared state, I would suggest we follow the principle of least surprise and just keep that in the class definition. And if we need a singleton, we should just use new. There's other ways of getting singletons too, but you might have a function outside the class that sort of works as a factory function that generates new instances that would just generate the single instance. But this is how I would suggest, if you really want a singleton class, how you should do it. Okay. Now I am out of slide material. I like to say I don't have all the answers, but I do have some of them. I'm going to update my answer on slots with this material soon on Stack Overflow, where I'm a moderator. If you have questions, Stack Overflow can be a way to get them answered, but it can be risky. You may be not feel as welcomed as you could be on the site. It's far easier to get involved by answering questions. What I try to do is answer canonical questions and improve questions with the Python tag. So I look for questions that get lots of views, and I try to write really good canonical answers to those questions. So I may not be helping people who are asking questions today, but perhaps they're asking Google that question, and then I'm helping those people. Are there any more questions? Yes? No, what's your question?
With regards to saving space, right? If what we need is attribute access, you suggest maybe name tuple would be a better option, or not?
I'm not suggesting name tuple would be a better option. I'm suggesting it's actually comparable, but it's also less extensible. So if are named tuples actually better? And I'm not saying they're better on actually any dimension, except that they are immutable, and they are actually tuples, so they're intended to be used as tuples. You can make a slotted class that works like a mutable tuple, and sort of give it a way to iterate over it, and such that it works also like a tuple. So I wouldn't suggest named tuples are better. They're different, but they're pretty close in terms of performance.
And space, or not?
They're just as good on space. I would suggest they're no different on space, and I would suggest there's very little difference in time.
Thank you.
Yeah. Any other questions? I can lecture you on how to Stack Overflow. I have 5 minutes. Who wants that?
Yeah, I like that.
You would like the lecture on Stack Overflow. How to Stack Overflow. Okay, so for writing answers, give your answers a TLDR. I gave this talk a TLDW. Give your answers a TLDR. Try to be correct. Use the comments. Ugh, that's a long one. I even have a critique of the Python documentation on slots, and I'm going to stick around for the sprints, and hopefully I can get some changes into the documentation. Use comments to critique. So please look for my material and comment if you think I'm wrong on something. Use them to critique. Don't use them to say thank you. Don't use them. Use the upvote to say thank you. Use the downvote to say it's not a good answer. But even better than the downvote to say it's not a good answer, write a comment that says directly what is wrong with that answer. Take your time, make sure it's a good comment, and if people are wanting to argue with you, don't argue. I'm a moderator on Stack Overflow, so I see what happens when there's back and forth, and sometimes things escalate, and it's not a good situation. Try to make your best comment your first comment, and then walk away. That's what I would do. Usually not a reason to go back and forth. Use the comments to critique, use the comments to the questions to ask for more information. But, so what we're looking at is actually the moderator view. So I'll zoom in a little bit, and we'll ignore that information there. So comments, ask for more information on the questions. When that information is there, get them into the questions. You can edit, even with very little reputation on the site. And in fact, if you get your edits accepted, if they pass review, 5 people will, I believe, look at it and approve. And if they approve, you get 2 reputation points, up to 500 edits, and up to 2,000 reputation points, over which you will get the ability to make edits directly without going through review. Now, of course, it will be reviewed by the community who will look at it in the future. Yes? How much time did it take me to add to this question? Oh, to
on average, answer, I know you put a lot of effort into it.
I did.
How much time?
I don't know. I probably put 20 to 40 hours on this answer alone. We can look at the edit history. Anyone can look at the edit history. You can see this has had 34 edits to it, mostly by me. So you can see how it was in its original state. You can see things that I maybe got wrong and then went back and corrected. You can see the whole history. And this is all Creative Commons licensed. The code here is also MIT licensed, I believe, and so feel free to use it. Are there other questions about Stack Overflow or slots? Yes?
Well, I was sorry if I don't know if someone else wants to ask a question. Right, anyway.
Go ahead.
So I would like to also contribute documentation to this, but I find it sometimes hard with all the things that go on in my daily life. How do you do it? How do you find the time?
I just do it organically. I try to, if I get an upvote on something, I will look at it, probably, and I always look at things critically. So I'm looking at my own material critically, and I'm trying to fix it and make it better. And another thing you can do with answers is critique other answers in your answer, and then that helps other people learn, not only what's right, but also what it's incorrect. And then when they see something that's contradicting, maybe they can downvote it. Another issue with Stack Overflow, it's been around about 9 years now, I think, and so some of the answers are outdated, and they've been upvoted quite a lot. So we need to have lots of voting to counter that. Comments are even better. You have one downvote, you have a comment, and other people will downvote based on your comment. So that's a way of leveraging your influence to better help us sort the answers on the site. I have about 30 seconds left. No? Any other questions? All right, thank you. Enjoy the rest of the conference.